Okay, so remainder theorem, which is a shortcut to long division, used to determine if a divisor is a factor quickly without doing the long division. So in the first bullet, it says if p of -4 equals 0, then -4 is a solution or a root or a 0 or an x-intercept. Okay, we'll go with 0 of p of x. Okay, and if we turn that x equals -4 into x plus 4, then that would be a factor. Okay. Next one says if x plus 4 is a factor of p of x, then -4 or x equals -4 is a 0 of p of x because p of -4 would equal 0. Okay. Last bullet there, if x plus 4 is not a factor of p of x, then -4 is not a 0 of p of x because p of -4 wouldn't equal 0. Okay? When a value is inputted into a polynomial, the output will be the remainder. Okay? The same remainder as when that factor is long divided into the polynomial. Okay? So quick, easy way to tell if you have a remainder. Okay? All right, so let's go ahead and try number 3. It says if the ratio was placed in the form where q of x is a linear function, then which of the following is the value of r? So remember r, they want to know what the remainder is. So we have two options. We could long divide, or we can take x minus 9, turn it into x equals positive 9. Okay? And we can take our polynomial and replace all the x's with 9. And let's see what we get. So 9 squared minus 11 times 9 plus 22 in our calculator comes out to be 4. And so our polynomial with 9, we plugged in 9, okay? P of 9 came out to equal 4, all right? And therefore, since they want to know what the remainder was, it's 4. Okay, which tells us that x minus 9 is not a factor. Okay. All right. It says without using long division, determine if each of the following are factors of the listed polynomials. Explain why or why not. So without using long division, they want us to take the shortcut. They want us to use the remainder theorem. Okay. So is x plus 5 a factor? We don't know yet. But we're going to turn this into x equals -5. And now we're going to do p of -5 equal to 2 times -5 squared plus 9 times -5 minus 2. We're going to put that in our calculator and see what we get out. Okay, so 2 times -5 squared plus 9 times -5 minus 2, hit enter, and it equals 3. That 3 is the remainder. All right, which means that x plus 5 didn't go in a whole number of times, and therefore it is not a factor. We would not be able to factor this, okay? Or if we could factor, it wouldn't be x plus 5 as one of them, okay? And so now we can go ahead and say that x plus 5 is not a factor because p of -5 doesn't equal 0. And that's how we know, okay? Number 5. They want to know if x plus 1 is a factor of this polynomial. So we're going to turn this into x equals -1. And we're going to replace all the x's with -1. And we'll type it in just like we're writing it. And once I type it in and I hit enter, it comes out to be 0. And now I can answer the question. X plus 1 is a factor because p of -1 equals 0. Okay? Which means x plus 1 goes in a whole number of times. Okay, your remainder would be 0. All right, guys, number 6. And then it says, for what value of k will x minus 4 be a factor of that? All right, so what we're going to do is we're going to turn this into x equals 4, and we're going to go ahead and plug it in, although we got that weird k value. But if I replace all the x variables with 4, I will only have one variable left to solve for. Okay. Now, they said for what value of k will x minus 4 be a factor? So since it is a factor, this should come out to equal 0. And we need that equal sign in the 0 because remember, we're solving for k. You can't solve for a variable without an equal sign. All right, so this is 16. K times 4 is 4k. I'm just going to turn that around. Minus 52 equals 0. 16 and negative 52 combine to be a negative 36. And if I add 36 to the other side, 4k is going to equal 36, and I divide by 4, and k comes out to equal 9. And there's my value of k. All right, guys, I'll see you guys on the next page of notes.